Okay, so in this video here, we're going to be talking about how to find the inverse of an exponential. And the inverse of an exponential will always be a logarithm. And the inverse of a logarithm will always be an exponential. So in all of the examples that we're going to be dealing with in this video here, we're going to start with an exponential and we're going to take the inverse, and that will result in a logarithm. So what I want you to look at before we start any of these examples is the following. What you see in white right here is the template that we're going to be starting out in whenever we have an exponential. We're going to have y equals our base to the x power. Now in red, this is what happens when you take the inverse. So when I take the inverse of an exponential, the result will actually be another exponential, but it's actually going to be a logarithm. So for example, this part right here is actually the exponential form of a logarithm. So a logarithm has two forms. You can write it as a log, like you see down here, okay? Or you can write it in its exponential form, like you see on this one here, okay? So the exponential form is always the result right after you take the inverse, meaning you switch the x and y value. But we don't want to leave it like that. I don't want to leave it as x equals b to the y power, right? We never want to leave something as x equals. So to get around that, we can write it in its log form. And that essentially will be y equals, and then again, we have log base b of x. So the key takeaway here, these two equations that I have in red are the same. If you were to graph them, they're going to be exactly the same. They're two different forms, but again, we want to write it in its final form, which is going to be the log form. We don't want to leave it in its exponential form. So again, a logarithm does have an exponential form, but typically you're seeing it written as a logarithm. So let's go ahead and take a look at our first example here. Let me go ahead and get rid of all this here. And whenever you're taking the inverse of an exponential, your first goal is to always isolate the base and the exponent. So for example, I can see that my base here is 5 and my exponent is x. I have the entire thing isolated. I don't have to do anything else here. But let's say you had like plus 1 here, okay? Before you go and take the inverse, you would have to take this positive 1 and move it over to the left-hand side, meaning you would subtract it. And then once you do that, then you would take the inverse. And we will have examples like that after this one here. So let's talk about how to do this one first, though. So I know that it's completely isolated. All I have to do now is switch the x and the y value. That is taking the inverse, right? When we switch the x and y value. So I'm going to go ahead and do that. That will give me x is equal to 5 to the y power. So when you make that switch, what happens, you are now in this form right here, okay? So technically you're done, but again, we want to write it as a logarithm. We don't want to leave it as a log in its exponential form because again, this is a logarithm right here, okay? But we want to write it in its log form. So to do that, all we have to do now is rearrange. So using our template right here, and using our values right here, we're going to rearrange. So that will give me y is equal to log, and then I'll have a base of 5, and then of x. And here it is. Okay? So again, just to reiterate, if you were to graph this one here and this one here, they're going to be exactly the same. All right? But this is the format down here that we want to be in. Okay? So there's the inverse. Let's go ahead and try a few more examples here. So here's our next example, and remember what you need to do first. You need to go ahead and isolate that base and the exponent, meaning this negative 1, I have to move over to the left-hand side before I make the switch between the x and the y. So doing that, I'll get y plus 1 equal to 4 to the x power, okay? Now I'm going to go ahead and make the switch. So now I'll have x plus 1 equal to 4 to the y power. So again, all I did there was switch the x and the y value. So technically, I'm in this format now right here. After you make the switch, you end up with a logarithm, and in this case here, we're in the exponential form. So this is where it can get a bit tricky. You have to understand that this whole part right here is like your x. So this whole part here is like my x. Here's my base, and then here is my y, right? So looking at this format right here, when I move the x over, I'm going to be moving over this entire part here, x plus 1. Okay, that's important to understand. So rewriting it, you're going to have y is equal to log, my base is 4, and then my x, again, is going to be this entire part here. So of x plus 1. And then we're done. Okay, so there's the inverse. All right, let's go ahead and try 2 more examples. So here's my next example. And again, this one's going to be a bit more difficult. But you want to go ahead and isolate the base and the exponent. Now, this whole part here is my exponent, okay? And my base is 7. I have to go ahead and get rid of that positive 2. So I'm going to go ahead and subtract it. So I get y minus 2 equal to 7. And then all to the power of x minus 2. So now that my base and exponent is isolated, I can go ahead and switch the x and y values. So doing that, I get x minus 2 equal to 7, and then all to the power of y minus 2. So again, now I'm in this form right here, okay? It is a logarithm, but I'm in the exponential form of a logarithm. So at this point here, I like to go ahead and label everything. This entire part right here is going to be x, okay? And then my base will be 7, and this entire part up here, my exponent, is going to be y. Okay, so think about how you're going to make the transition now going to log form. My y is y minus 2. So I'm going to go ahead and write it as y minus 2 equal to log, and then my base is 7, and then of my x, which is x minus 2. And then from here, you have one more step. I don't want to leave it as y minus 2. I want y equals. So I need to take this negative 2, and I need to add it on both sides, and then I'll be done. So let me go ahead and scroll down just a little bit. And doing that, I'm going to go ahead and get y is equal to log base 7 of x minus 2. Adding over the 2, I get plus 2. And here we go. We are done. Here is the inverse. Okay. All right. Let's go ahead and try one more example. Okay. So here's our last example. And again, let's go ahead and identify our base and exponent. So right now, my base is 2. Okay, and my exponent is x plus 3, meaning I need to go ahead and get rid of this negative 3. I also have to get rid of this denominator of 3 right here, okay? So first, we're going to go ahead and add 3 on both sides. So we get y plus 3 equal to 2 over 3. And again, that 2 is to the power of x plus 3. Again, by adding 3, I get rid of the negative 3 right here, right? And now from here, we have to get rid of that denominator of 3. A simple way to do that is to multiply both sides by 3. So if I multiply this side by 3, again, it will cancel out here. And multiplying this side by 3. Now, remember, I have to multiply both of my terms here. So you may want to go ahead and draw arrows in, okay? You could also put parentheses around y plus 3 if you wanted to, but I find it's going to be easier to go ahead and just distribute that 3. So I'm going to get here 3y and then plus 9. Equal to 2 to the power of x plus 3. Okay, so now our base and our exponent is isolated. Now we can go ahead and make the switch. We're going to go ahead and switch the x and y values, and then we will essentially have the inverse. We'll just have to go ahead and put it in its log form at the end. So making the switch here, we get 3x plus 9 equal to 2 to the power of y plus 3. Okay, so now I'm in this form right here. And this entire part here is going to be my x. Okay, my base is going to be 2. And my exponent here of y plus 3 is going to be my y. Okay, so now we can go ahead and rearrange it into its log form. Let's go ahead and scroll down. Rearranging it, we get y plus 3, that's my y, equal to log, and then my base here is going to be 2, of my x, 3x, plus 9. And then my last step here, I have to get rid of this positive 3, meaning I'm going to subtract. So my final answer here is going to be the following. I get y is equal to log base 2 of 3x plus 9, and then finally minus 3. And there it is. There is my inverse. Okay? And that is it. So that is how you can find the inverse of exponentials. It's pretty straightforward, but you do want to make sure that you have these templates written down. So again, if I scroll up right here, you want to make sure that you have these templates in the top left-hand corner here. It's going to make doing the problems much easier. And again, just remember, when you are finding the inverse, make sure that you isolate the base and the exponent first. And then from there, you can go ahead and switch the x and y values and go from there. So that's going to do it for this video. I hope that you gained something from it. I hope that you learned something. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future, and I'll see you in the next one.